The x-coordinates at the point or points of intersection of the curves with the equation y equals fx and y equals gx are the solutions to the equation fx equals gx. For example, on the same axis, sketch the curves with the equation y equals x minus 2 times x plus 2 squared and y equals minus x squared minus 8. So first, let's sketch the graph of y equals x minus 2 times x plus 2 squared. When x equals 0, y equals minus 2 times 2 squared equals minus 8. And when y equals 0, x equals 2 or x equals minus 2. Here, x equals minus 2 is a double repeated rule. So, this is a cubic graph with a positive x cube coefficient and hence the graph would look like this. Now, let's sketch the graph of y equals minus x squared minus 8. So, when x equals 0, y equals minus 8 and when y equals 0, x squared equals minus 8. There are no solutions, so the curve y equals minus x squared minus 8 doesn't cross the x-axis but crosses the y-axis at minus 8. Now, this is the graph of y equals minus x squared minus 8 as the coefficient of x squared is minus 1. As you can see from the graph, there are 3 points of intersection. So first, let's label them as A, B and C. Now, to find the coordinates of the points of intersection of the graphs, let's write down a suitable equation. In order to find the x-coordinates of the points of intersection, set the two equations equal to one another. Then it's x minus 2 times x plus 2 squared equals minus x squared minus 8. There are 3 points of intersection, so the equation x minus 2 times x plus 2 squared equals minus x squared minus 8 has 3 real roots. So first, expand the brackets, then it's x minus 2 times x squared plus 4x plus 4 equals minus x squared minus 8. Further expand in the brackets gives us x cubed plus 2x squared minus 4x minus 8 equals minus x squared minus 8. So, x to the power 3 plus 3x squared minus 4x equals 0. Here, x is a common factor, so take it out to factorize. X times x squared plus 3x minus 4 equals 0. Further factorizing gives us x times x minus 1 times x plus 4 equal to 0 and hence the solutions are x equals 0, x equals 1 or x equals minus 4. In order to find the corresponding y coordinates, substitute these x coordinates into one of the equations. So let's take y equals minus x squared minus 8, then for x equals 0, y equals minus 8. When x equals 1, y equals minus 1 minus 8 equals minus 9 and when x equals minus 4, y equals minus 16 minus 8 equals minus 24. So, the coordinates of the points of intersection are 0, minus 8, 1, minus 9 and minus 4, minus 24. So, if we check with the graph, the coordinates for A are minus 4, minus 24, at B it's 0, minus 8 and C it's 1, minus 9. Now, let's take a look at another example. On the same axis, sketch the curve y equals x to the power 3 minus 3x squared minus 4x and the line y equals 6x. So, here's the graph of y equals 6x. Now, let's sketch the curve of y equals x cubed minus 3x squared minus 4x. When x equals 0, y equals 0 and when y equals 0, x to the power 3 minus 3x squared minus 4x equal to 0. Factorize to find the x values, then it's x times x squared minus 3x minus 4 equal to 0, x times x minus 4 times x plus 1 equals 0. So, x equals 0, x equals 4 or x equals minus 1. This is a cubic graph and would take a shape like this. This cubic graph crosses the x-axis at x equals 0, x equals 4 and x equals minus 1. As you can see, there are 3 points of intersection. In order to find the coordinates of the points of intersection, first solve the equation x cubed minus 3x squared minus 4x equals 6x. So, x to the power 3 minus 3x squared minus 10x equals 0. Factorize, then it's x times x squared minus 3x minus 10 equal to 0, x times x minus 5 times x plus 2 equal to 0. X equals 0, x equals 5 or x equals to minus 2. Now, to find the y coordinates, substitute the x values to the equation y equals 6x. So, when x equals 0, y equals 0, when x equals 5, y equals 30 and when x equals minus 2, y equals minus 12. and hence the coordinates of the points of intersection are 0, 0, 5, 30 and -2, -12. So if you check the graph here, you can see the coordinates of the points of intersection.